Any questions? Today's 29th, Wednesday, right? So let's recap what we did yesterday, which we did some deriving yesterday, right? We're gonna do a little bit more deriving, and then we're gonna get back to tangent. We're gonna get back to tangent, right? And maybe even cotangent. And if we have time, we can give you a little intro about secant, cosecant, and mainly, yes, some of these functions we might use them a lot. Some of them we just maybe we use a little. But the main thing I want to show you is to guide you guys to how to analyze, okay, the analytical skill, and some basic algebraic skill, right? And these two must be combined together. Otherwise, you cannot go very far. So on the one hand, you have to understand the basic, where they came from. And number two, then you have to be able to manipulate those algebraically so that you can deal with those complicated situations in calculus classes. So that's what I encourage you guys to follow me. And the other thing I will mention about the deriving part, which I will address this if I have time, otherwise we'll address them tomorrow, is that you must start deriving now as soon as possible, if not sooner, okay? If you didn't do it sooner, then you should start to do it as early as possible, okay? And because you will need those skills. So yesterday we talked about that. So far, everything we have done is by dig into the definition, right? And yet, as definition was introduced very early on in a trig course, later it was expanded into different chapters. There's only so much you can hold in several pages or 10, 20 pages in one chapter, right? So it was expanded, but now we're gonna bring them all together to see how they are all originated from the same source, which is ARD, right? Which is ARD. So yesterday we derived this, famous identity. From this identity, we have derived the other one. These two are used very often, okay? And you can see where it came from, right? It comes from the definition. And if you dig even deeper, it comes from Pythagorean theorem. If you dig even deeper, it dig into that whole setting of ARD, right? Remember that stage we said? ARD, right? That's where it is from. That's where it is from. So if you just master these basics, everything else is at your fingertips. You just derive it. You don't have to memorize a whole lot of things at all right? All right, some of you who have not taken trigonometry, which I also try to take care of you, you might not be very familiar with this unit circle. Okay, you might not be very familiar with this unit circle. Okay, I'm going to get to it maybe tomorrow. Okay, maybe tomorrow. Okay, but today we're going to go as planned. Okay? Okay, so without further ado, let's dig in from the definition. Okay, so ARD again. ARD again. Okay, in the definition of sine, cosine, tangent, cotangent, secant, cosecant, what I do is that I rearrange them. Okay, I bring sine and cosecant together, and I bring cosine and secant together, and I bring tangent and cotangent together. What do we see? What do we see? What's the relationship between sine and cosecant? We have covered the domain, right? We have covered the domain. When in the situation, they're reciprocals, absolutely. They're reciprocals. What does reciprocal means? Reciprocal means sine of A is 1 over cosecant of A, right? And what is more, cosecant of A equals to 1 over sine of A, cosecant. And what is more, if you multiply sine of A, okay, with the cosecant of A, you should equals to 1. So this product equals to 1. You see another way to express 1. Remember, anything times 1 stay the same. Anything times 1 stay the same, right? So you can just use this product as 1. Of course, all of these provided, right? The angles are in the domain for both functions, okay? The reason I'm addressing this because the domain and sine of sine A and cosecant A are not the same. Okay, so cosecant has a smaller domain. So all of these, okay, yesterday we did the domain and range summary, didn't we? Right? We talk about that, you know, cosecant, right? We look at the domain for let me bring this up. Let me bring this up. Okay. So when we are doing this, we need to be aware of the domain. So the underlying assumption as we are doing this is that the domain requirements for sine and the domain requirement for cosecant are both satisfied. If they're both satisfied, that means the angle cannot be multiples of pi. Okay, so these assumptions are made usually by default. Are these default always mentioned? Not necessarily in the textbook, but we need to be aware of it. For example, in the textbook of trigonometry, right? In the textbook of trigonometry, right after the definition was introduced, these relationships were mentioned in that textbook. But it's only in chapter 3 or chapter 4, domain is talked about. So at that time, the domain actually was not quite mentioned. Okay, but it should have been. It should have been. But so now you look back, you bring these things together. Sometimes the textbook might leave out something, not intentionally. I think in most situations, you know, I cannot speak for the author. The author might have his own reason, but we must think rigorously. We must think rigorously, even though sometimes something might be left out, and we need to fill in the gap. We need to fill in the gap. Otherwise, the soundness of mathematics will be questioned. Right? So domain is always something in the back of our mind. In calculus classes, every day you deal with those functions, you are supposed to know the domain already. And the domain is not going to be the big topics anymore in calculus classes. Okay? All right, so this is the situation. This is the first one. The second one, if you look at a cosine and a secant, once again, they're reciprocal to each other, right? They're reciprocal to each other. So the same relationship happens again. And from these relationships, actually, there much more can be derived. We just cannot stay here forever. That's why I want to send you guys to the identity deriving part. Okay, so cosine A. So these are the very basics. Okay, these are the very basics. So secant A equals to 1 over cosine, which we used yesterday. And what is more, and you need to be very, I would say, comfortable. You need to be very comfortable at writing these down in the course of your work. Okay, the consequence of not being able to do that, what is the consequence of not being able to do that? First, it reflects your deficiency, first of all, it would reflect our deficiency in algebra manipulation. And secondly, you cannot make it in calculus class. Calculus class, you deal with even more complicated algebraic expression. Okay, after you take a derivative, you have to simplify that, right? That covers, 2-3 chapters. So if you don't get the basic right, then you will have a very hard time. You have very, very hard time. So one thing is to understand, that's why when you watch what I'm doing, you must do it on the side at the same time. And after class, you do it again. I'm speaking from my own experience. You cannot be just a spectator, right? It's just watching a sport. Right? So in this case, you not only see how the game is played, you also have to get in the game and play the game. Play the game. Okay, so now let's look at tangent, cotangent. So tangent is reciprocal of cotangent. And secondly, cotangent is the reciprocal of tangent. With all these implications, right? So tangent multiply cotangent is equals to 1. Okay, so these are the reciprocal relationship. And from these basics, a lot, tons of identities are being derived. You typically would see that in the textbook of trigonometry. So the material I put together, which I already assigned you for homework, titled Trig 17. Okay, Trig 17, Trig 18. Okay, I have A, B. So for now, you may like to get to A's. If you're done with A's, get to B's. Okay, you're taking 5 classes in one. I don't imagine you have a lot of time to not to do this. Okay, deriving one identity up, and all at the same time, you're enhancing your algebraic skills from the basic pre-algebra all the way up to trigonometry. Okay, and over time, some questions will be picked from this area, but now I have started to assign you the homework. Okay, so without further ado, we're going to get back to tangent, right? Because we're still working on basic 1. We're still working on basic 1. Okay, so all of these functions domains are covered. For sine, cosine, domain, and range are both covered. X-intercept are covered. You can see the connection, but we haven't get the range of tangent and cotangent. Tangent is much used in calculus because this function is very, very special, very, very special. Okay, so sine, cosine, tangent are much used. Other functions are also used, but with little less frequency. So let's get to them. Okay. So on this part, we did that. Let's look at tangent. What is the definition of tangent? Let's go back to ARD, right? We're back. We have been in ARD for how long? More than a week now, right? More than a week now. everything is related to ARD, right? Everything in trig is related to ARD. Okay, so next, before we do the summary for tangent, okay, and today I'm going to be I want to I want to speed up a little bit. Okay, I want to speed up a little bit. So what I would do, okay, what I'm going to do is that I'm going to make you guys plot points with me. Okay, just like what we did with sine and cosine. Okay, so let's get to tangent. Let's get to tangent. By the way, I wish you guys give me some feedback whether you want me to go over these points on the unit circle tomorrow. Okay, I have prepared some material. Okay, so you guys want that. Okay, we'll do that tomorrow, right? Because for those of you who have never taken trigonometry, this is like you're suddenly thrown into a cold water, right? Icy water. You say, what is that? Okay, so thank you for your feedback. So we're gonna do that tomorrow. But anyway, without further ado, let's look at tangent. So I'm gonna start from the basic. Okay, I always want you to start from the basic. From the basic, everything can be built soundly. Okay, everything can be built soundly. And you don't have to memorize a lot of things. Okay, so this is a rectangular system. Okay, so what do we want to do? Okay, we have done sine and cosine, right? You guys still remember what we did with sine and cosine, do you? Yes?
Yes.
Okay, and you should have done it yourself. Okay, you must do it yourself. So everything I have done in class, if you think it's helpful for you, I want you to remember I did it. You are most of the time just participants part of the time. You need to commit yourself to do it yourself. Okay, so now what do we want to do here? What do we want to do here? What do we want to do? We're going to get a picture that would do the arc length, right? For example, for pi over 6, right? We're going to have the arc length of pi over 6. Okay, this is the arc length. And I'm going to stretch it straight. I'm going to stretch it straight. And but the vertical, that's the input, right? Remember, that's the input. And what's the output? The output is not going to be, it's neither going to be blue nor red. But that output is going to be the ratio. The ratio. Okay? And that ratio is defined by tangent. Okay, that ratio is defined by tangent. So how is that defined? Okay, so that's our idea. So let me make just a little bit of adjustment because the scale doesn't seem right. Okay, so what I'm going to do is I'm going to change the scale just a little bit. Okay, because I don't want that to bother you. Don't want that to bother you. Okay, and the scale is a little bit off because you can see this is 2, that's 1. So I'm going to make this just a little bit closer. Closer yet. Never mind, let me do this. Okay, make it 3. How about that? So we're going to look at a part of a picture. Do you guys follow me? So what do you think I'm trying to do? What do you think I'm trying to do? I'm trying to make this one about the same length visually as the other one. You guys follow me? That's what I'm trying to do. So make it like number seems correct, okay? You guys understand, right?
Yes.
Okay. So now I measured by my eyes. It doesn't have to be perfect, right? So this scale and that scale, it's about the same, right? It's about the same. Yeah. So now we get started. So the kind of picture we're getting, right? You can get it at your fingertips, right? You just type tangent X that they're going to give you a curve. That's easy, very easy. I know you guys can get that. But we want to understand that graph, right? We want to understand that graph. So in order to understand this graph, we have to look at the details because the devils are in the details. So what we still do is that say for pi over 6, right? Recall what we did for sine. If we measure a terminal at a pi over 6, right? And we will measure the arc length. The arc length is a measure from the same place. Oh, never mind. I need to curve it. That's the arc length, right? And this arc length is going to be stretched straight. Okay, something like that. Pi over 6. That's how long it is. And it corresponds to the angle pi over 6, right? It corresponds to the angle pi over 6. And then the ratio, so that's the, excuse me, that's the input, and the ratio, okay, is going to be the ratio for tangent, right? So for sine curve, we use the arc length as the input, and the ratio is the blue number. For cosine, the input is the same, and the output is for the red number. So how about for tangent? How about for tangent? How about for tangent? Tangent. Anybody want to say something? So tangent of an angle is equals to what? Equal to sine of the angle over cosine of that angle, right? Sine is the blue number, cosine is the red number. So what do we get? So this purple is going to be what? Is going to be the blue divided by the red. You follow me? So it's going to be the blue number divided by the red number. Does everybody see that? Does everybody follow me? Are you awake?
Yes.
All right, so let's do it. So we just, well, there's some blue numbers. We only have a finite number of blue numbers, red numbers here. So we're gonna do for each pair in order to get the points, right? So next we're gonna do the points, and you guys are gonna do it with me. Okay, are you ready? Okay. The same drill, But now this time we do the ratio. For sine, we do the blue. For cosine, we did the red. And now is the ratio. So what I'm going to do is I'm creating a table. Okay. This table starts from the simplest. Okay, start from the simplest. What you want the simplest? We just use a special angle, okay? Remember, the special angles are in services to a lot of the things we do. But the source of everything is definition. And the special angles are just a tool. Okay, they're just our tool. So what I like to do is I'm going to show you a couple examples for tangent. Okay, so for now, I'm going to make that just a little bit smaller. Okay, so the input angle, okay, the first one I'm going to use is pi over 6. Okay, and so you guys get familiar with this process, right? Pi over 4, pi over 3. Okay, you have that unit circle with you, right? And we're going to calculate the tangent ratio. So let me bring this table on the top. Okay, so let me bring this ratio, bring this table over here. They don't line up that extremely well. But I want you guys to, you guys are following me, right?
Yes.
So for these 3 angles, we're going to do the tangent ratio. Tangent ratio. Tangent ratio for tangent pi over 6, right? What would that be? It's going to be sine pi over 6 divided by cosine pi over 6. Any way you do it, okay? There's so many ways to express it. But with the visual here, it's just a blue number. Oh, we forgot the 0, didn't we? Why should we forget such a simple number, right? We should not. Let me insert 0. Let's insert 0, right? Shall we? Why not? Such an easy number. We don't want to miss that, right? So 0, right? And tangent 0. For tangent 0, that's the terminal that start from the standard position, start from here and end here, right? So that's going to be the blue 0 divided by the red 1. So that's going to be what? 0 over 1. 0 over 1 is 0, right? 0 over 1 is 0. Yes? The next one, it takes a little calculation. It takes a little calculation. So what do? We take the blue half, which is sine pi over 6, divided by square root of 3 over 2. Everybody start doing this simplification. Okay, remember we're taking 5 classes in 1, even though this is basic algebraic, this is a basic algebra skill, right? But we all need to review that. So can you reduce this fraction correctly?
Yes. Would the answer be radical 3 over 3?
Correct. Okay, so let's see how we get to it. Multiply, right? I will multiply a 2 on top and multiply a 2 on the bottom. Can you guys see? Is the font large enough for you to see? Are the fonts large enough for you guys to see? Yeah?
Yeah.
Okay, so we multiply a 2 on top divided by 2 on top. So as if we multiply the entire fraction by 1. Anything times 1 stay the same. It's principle number 1, right? And then 2 times half, that's equals to 1. And the denominator, we're going to get a root 3 because 2 and 2 reduced. And then we rationalize it. Well, how do we rationalize it? We multiply another 1 again, right? So what will this lead us to? We're going to choose that 1 to be root 3 divided into root 3. So we multiply by 1. Doing so, we got root 3 divided by 3. That's how we get root 3 by 3. All right. So now how many points have we got? 2 points. So the points input, comma, output, right? Input is the angle, output is the ratio. That's the picture we want to get to, right? That's a picture we want to get to. We want this direction is the angle, which is the arc length on the unit circle. And in this direction, we get to the ratio. It's a tangent ratio. That's what we want to. That's the picture we're getting, just like we did with sine, cosine. You guys follow me?
Yes.
Do you see, do you hear the amazing consistency that we handle mathematics? Do you hear that? That's what I want you to see. Mathematics, if anything, is super consistent from beginning to end. From beginning to end. Okay? All right. So now we got 0, 0. And we're going to plot the points 0, 0. And the next point is going to be pi over 6 is the input. And now I want you guys to set up your rectangular system. And you're going to put these 2 points in the graph. We're going to do more points for sure. Okay, we're going to do more points for sure. Okay, so put these 2 points on the graph. On the graph. All right. We're going to make it a red dot. And another one, 0, 0. 2 red dots. So the horizontal is the arc length, as we talk about in sine, cosine. That's the input. The output is the tangent ratio instead of sine ratio or cosine ratio. Okay, so if you are to mark these points, how would you mark these 2 points? This point is what? 0, 0, right? How about this point? Input pi over 6. Output root 3 over 3. If you recall what we have done for all of the functions so far in basic 1, are we being consistent in doing exactly what we did now? Exactly what we do now. Yes? Yes?
Yeah.
Absolutely, right? So if you, it's like you stand back, you look at the whole thing you do, you recall everything, then you say, oh, we've been doing the same thing all over and over again. It's just different function, different rules, right? Different function, different rules. So now with that said and done, I want you guys to do pi over 4 and pi over 3. Similar. I'm putting the points on the chart. Okay. Do we need a breakout rooms? I'm just going to give you like a 3 minutes. Would you do that for me? Let's go. If you want to break out rooms, let me know. Yeah? Okay, go for it. Okay, I'm just going to excuse myself for just 1 minute. Okay, I need to use the restroom. I'll be right back. My nose is congested. I'll be right back, okay? All right, so I saw some messages on chat. Okay. All right. So are you done? We start things from simple, right? We start things from simple. And then what do we see? As the input increases, right? You can see this input is getting larger and larger from 0. And the output gets larger and larger as well. You can see the point is going higher and higher and higher to the right, right? So on this piece, we see an increasing tendency as we have selecting our angles as input. What happens? We're getting closer. There are a lot of angles we didn't do in between, right? And there are also lots of blues and red, and we do the blue and red in between. We're just being lazy. We didn't do it, right? So we keep going. As we're getting closer and closer to pi over 2, we know we cannot take pi over 2 as input, right? We talked about that yesterday, right? So just like a child like to play, like to test his boundary or her boundaries, we're trying to say, hey, we get close to it, get close to it. What happens if I get closer and closer to it? You guys follow me?
Yeah.
So remember your childhood, you try to play, test the boundaries of a mother, right? Have you done that? I'm sure you did. I'm sure Jacob has done that. Right, Jake? I'm just kidding you.
I was gonna say, if I said no, I don't know if you would believe me.
Oh, you're the model child, but I know some of us have done that, right? I'm the perfect citizen. I have never done that, right? But never mind. I'm just joking, right? So this is like I'm testing my boundary. I know I cannot get there because if I get there, I'll be punished. I cannot be, but I can get closer, it's closer and closer and closer yet. And I wonder what will happen to the ratio. What will happen to the ratio? Do you want to find out? Shall we? So let's get closer and closer yet. Let's get closer and closer yet. Okay. So now we're getting closer and closer to pi over 2, okay? So we're getting closer and closer to pi over 2. We want to see what happens. But then there's no special angle there. So what do? We have to pick some, okay? So we're going to pick some radians and we're going to pick some degrees, whichever one you feel more comfortable. I wish you guys have a calculator with you. Do you guys have a calculator or whatever calculator you can get? I don't really care. You don't have to spend a lot of money to test it, right? So you know what we want to do next, right? We want to see as we're getting closer and closer to this forbidden number. Okay, this cannot be in the domain. So I'm going to mark that forbidden number. Okay. Right here. That forbidden number, I'm going to use yellow because I don't want to confuse the color, right? In soccer, I know some of us may be soccer fan, right? Yellow card is no good, right? Yellow card is the punishment, yeah? Yes?
It's a warning.
It's a warning. Okay, it's a warning. Farouz knows that it's a warning. You don't step in there, okay? So I'm using yellow. I'm not using red because we have red already. Okay, so we're testing the boundary. We're testing it. Okay, so that's the idea. So I'm going to choose some values for you guys to use your calculator on. Are you ready? Because as we start doing it, these pictures will disappear because I'm going to show you something else. The screen is limited, right? All right. With that said and done, Farouz, you have to teach me the rules of soccer.
I just know the yellow and red card. Yellow warning.
And red is what? Red is out.
You are fired.
You're fired. Wow.
Yes, you are out. You are out is correct.
I think a red line will be more, will be better, right?
Yeah,
Because
yes.
pi over 2 is out. It's out.
Yes,
Right?
red is
It's
out.
out. I'm sorry. So maybe we should use a red.
Red.
Thank you, Farouz. So next, I'm going to choose numbers closer to pi over 2, right? So I'm going to use pi over 2 minus, okay? So this number is going to be smaller than pi over 2. So minus 0.02. And the next number, I'm going to get even closer to pi over 2. This time pi over 2 minus 0.01, right? They're not a pi over 2 anymore, right? But they're closer and closer to pi over 2. This one is close to pi over 2, and this one is even closer to pi over 2. I want to know that value. I want to know that value. Okay.
We must be in radian mode, Professor, with calculator.
That's right. I'm going to take care of the degree mode. Okay. So I'm going to take care of the degree mode. Just hold on a second. So this is for those of you with radian mode. I'm going to give you the degree mode. Okay. The degree mode will be such as 88 degrees. If you want to use 88 degrees. Okay. 89 degrees. 89 degrees. Okay. 89.9 degrees. These are getting closer to what? To 90 degrees. Do you guys follow me? So what I want you guys to do is I want you guys to get the answer to these degrees. Okay, if you like to use degrees, no problem. If you like to use radians, no problem. What are we getting?
Do you want us to type in our answer on the chat, Professor?
Oh yeah, that would be amazing. I don't have a calculator, so I'm going to take a nap. You guys do the work. Or I'm going to play with my cell phone. Right?
So
I just watch you guys do the hard work.
Can I answer one of them?
Sure. Is everybody doing that? This is fun, or we're testing the boundary. We're testing the boundary of this function. We're testing the boundary. I don't see any numbers. Should we have a breakout rooms for this? So Farouz can help you guys get started using the calculator.
For the first one, I think I want to say 49.9, but I think that's wrong, is it?
Well, you can have a little confidence, right, Jay? You just make sure you use the tangent button and it's on radian mode. And whatever number you get is fine. But it should be a fairly large number.
Professor, if you use a degree tangent, for example, tangent 88 degrees, that's what I get 28.636 dot 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 in degree mode. And so when we have,
I'm going to copy for Farouz's work. I'm also going to copy Wilbur's work. Thank you guys so much. Okay, so tangent 88 degrees is that, right? 59 and 89 degree is, you guys amazing. You get work done, right? And tangent 89.9 degrees, we get this number. What do you see? 89.999. That number is huge. Obviously, you guys like degrees, but that's okay. Either one should show us the same pattern, okay? So you don't worry. So if you don't like to do the radian for now, that's okay, right? So just look at the degrees. The degrees tell us what? The degree tell us what? If before we use a degree, we should look at another pattern. Look at another pattern, right? Look at another pattern. I want you guys to look at the blue number, right? So I'm going to use the red for this piece because the red card to pi over 2, right? And then now the purple. You can see the blue number as the angle increases from 0 to pi over 2, the blue number is getting larger and larger, right? By the time it gets to pi over 2, it's equals to 1. So the numerator is getting closer and closer to 1. What happened to the red number? The red number from 1, smaller, 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 closer to 0. So you have a situation that you have a numerator, because tangent is sine over cosine. The sine value is getting closer and closer to 1, the denominator getting closer and closer to 0. Do you guys see that? That's a situation you are observing as you're doing tangent 88, tangent 89, tangent 89.9. Do you guys follow me? Yes? Are you guys with me? Okay. And the ratio of those blue number to the red number is getting what? Getting larger and larger and larger yet. In fact, it can be as large as possible. You follow me? That's what we saw, right? Yes. So let's organize these points. Let's organize these points. Okay, let's organize these points. Okay, for this point, how do you plot it? You cannot do 88 degrees, I'm sorry. You have to convert 88 degrees to radian. Okay, 88 degree to radian. Do you know how to convert 88 degree to radian?
Do like pi over 180 degrees. Or am I wrong on that one?
Yeah, since we're here, let's just talk about how do we convert it to radian? We know pi is 180 degree, right?
Yeah, you do.
1 degree is pi divided by 180 radian, right? So to convert 88 degree, what do we have to do? We need to multiply this. We need to convert, because to put it on the chart, you have to have that radian. Okay. And what do we do? So you're gonna have pi in the numerator. Denominator is 180. Okay, that's the radian. And the ratio is 28.6. For 89 degree, you do the same thing. 89 degree. You also multiply pi over 180. That gives you the radian. And the output is 57.3. Yeah? The next one. 89.9 degree. 89.9 degree. Yeah, you guys like degrees, huh? No problem. I can understand that. Sorry. Pi over 180. Multiply pi over 180, comma, this time 572. Okay, last one. We can keep doing this, right? Can we? We can keep going, but we already see the pattern, right? What happens? The input is getting closer and closer to 90 degrees. The output is getting closer and closer to very large number and larger yet. In fact, the output can be as large as possible. That's what I want you to see. Now, let's look at the pattern again. As we're getting closer and closer to 90 degrees, oh, sorry. Okay, as we're getting closer to 90 degrees, okay? Since you guys like to do the radian, so I'm gonna remove, like to do the degrees, I'm gonna remove the radian for sure, okay? So as the angle getting closer and closer to 90 degrees, okay? From smaller than 90 degrees, from smaller than 90 degrees, look, 88 degree, 89 degree, 89.9 degree, 89.999 degree, they are what? They are all smaller than 90 degree, i.e. in radian, the angles are getting closer and closer to pi over 2 from what? From smaller than pi over 2. What happened to the output? Tangent of these angles are approaching what? Positive infinity. Okay? It doesn't matter how you measure the angle. It really doesn't. Tangent approaching positive infinity. So what do we see that on the graph? Right? And you guys are going to plot these points. Of course, in order to plot these points, you're going to have to calculate these. Okay, shall we? Shall we calculate them? Yes? You can get rid of the degrees. Okay, you can get rid of the degrees. Because they reduced, right? Reduced. Yes?
Yes.
I want you guys to do the calculation and plot the points. Now you know the formula, right? 88 degree equals to 1.535 radian. Thank you, Farouz.
You're welcome.
Okay, so 88 degree equals to what? I'm going to write it as 1.535 radians. And the output is 28.6. And the next one. I need help. You guys need to help me. Please help me. Will you? Right, I want you guys to calculate those radians. So this way you get to know how to calculate radians. Okay, so give me those radian number. I'm relying on you. Come on, guys. All right. I appreciate the help. Thank you, Wilbur. So 89 degree is that radian is 1.55. 89.9 is that radian is 1.569. And the next one is what? 1.57. Very
Also-
close. Yeah.
Also, while we are here, there is a typo on the output of that line. 89.999 equals 57295.8. There is a double five, needs to be single.
You mean here?
Yes, two fives
57.
must be only 1 5. 57295.8.
This one has 1.5?
Yes,
Oh. Thank you.
you're welcome. I checked it with calculator, so
Okay. Thank you. Okay, great. Thank you so much. All right. So with the radians, which is the arc length, remember those are the arc lengths, right? I'm going to put those points on the graph. So we have to seriously adjust the picture because my current picture is from horizontally from -3 to 3, vertically from -3 to 3. My vertical has to be adjusted to what? To what? To what? To what? Tell me. This is 57,000. I should have to adjust it to 58,000, something like that, right? So you're gonna see a little twitching of the curve, the points, okay? So these points will be cluttered together because we have changed the scale on the vertical direction, okay? So now we have to do it because we want to see those points, we have to do it, right? Ah, let's do that. I'm not even sure if this software can handle this. So 58,000. Oh my God, let's see that. I've never done that before. Oh my God, look at that. Those points, they're like almost touching x-axis. It's not because they're touching x-axis, because they're considered too small compared to infinity, right? So let's plot one of the points. Let's plot one of the points. I think you guys already got the idea, haven't you? Yes? Have you got the idea already? Where's that point? Oh gosh. I have never done this with other classes before. So the consequence is it's way higher there. Okay, it's going to be way higher over there. Okay, it's probably this one, right? Let's plot the largest one, the highest one, 1.57. 1.57. I'm going to put this number in the graph. That should show up. Oh my God. 50,000. Maybe my scale is not 60,000.
that might be an idea.
Where is it? 1.57, 572, 60,000. 60,000 should show. Right? Oh, you know what? I might have made a mistake. I need to make sure those points. Oh, I didn't do the dots. That's why. Sorry. Do you see the dots? Oh, finally. So what happened to the curve is that on this piece, okay, I'm going to draw the tangent curve for you now, right? So on this piece, right, the tangent curve is just like shooting up, shooting up, okay? Boom, goes up. And this area, you don't see much, right? So I need to make some adjustment, okay? All right, let's see. This is a little bit. Let's see. It still doesn't show. Oh, wait. I think this software cannot handle it. It cannot handle it.
I guess
Okay,
you
but
are
never
push.
mind.
I guess
Huh?
you are push. I guess, Professor, you are pushing the limit of the software.
I am pushing the limit of the software. That's a good point, right? As we're pushing the limit of pi over 2, and I have to push the limit of software. So let's get back to normal, okay? So let's go back to the to this guy, okay? So let me do just still 3, and this is a -10, and that's to a manageable situation, right? So what happened to the other points I plotted earlier? They're shooting up, way up. Okay, so this piece of exercise, I want you guys to see that the curve is increasing, going up, and at certain point, as it gets closer and closer to pi over 2 from smaller than pi over 2, the speed of going to infinity is much expedited. It's getting closer and closer to infinity. Have you guys, and it's getting closer and closer to a vertical line. Does any one of you know what is that vertical line? Do you remember something called vertical asymptote? Yeah?
I remember yesterday one of the students mentioned that.
Yeah, vertical asymptote. Let's draw that vertical asymptote. Okay. That vertical asymptote I'm drawing here. Okay. Broken line. Forbidden. That. So the curve is getting closer and closer. So what we observe is that as the input getting closer and closer to pi over 2, it cannot be pi over 2 because pi over 2 is a red card. You can't touch it. Can't touch it. Otherwise, you're out. Pi over 2 is out. The output, okay? The output is getting higher and higher and higher yet. As high as possible, as high as you wish. Okay? And this process we just did, okay? We spent so much time doing this process. And what do we learn? And to describe this process using calculus notation, is that when the angle approaches 90 degrees from smaller than 90 degrees, where the angle input approaches pi over 2 from smaller than pi over 2, the output is approaching positive infinity. That's the dynamic process this notation represents. Do you guys follow me? Yes? And I want you to understand this. You're going to use it in Cal. You're going to use it in Cal. Got it? So we have the numerical calculation, and we have the visual, and we have the frustration that our computer software is limited representing this whole thing. So that makes it ever more important for us to have that mental visualization. Okay, that mental visualization. Okay, all right. So now, so this is just on this side, on this side. And then you see there's something on the other side, right? There's something on the other side. So you wonder what's going on the other side. So in order for you guys to see the other side, in order for you to see the other side, we have to continue the plot. We want to continue the plot. It looks like this piece of curve is what? It's increasing. And there are other pieces too. Okay, but tangent function is not increasing in its domain. It's increasing in certain in those individual intervals. Okay, so now I'm going to give you some more points. I'm going to give you more points. Okay, I'm going to give you more points to calculate. Okay, so what are these more points? I'm going to give you negative pi over 6, negative pi over 2. Okay, so come on, you guys, roll up your sleeve. Pi over 3, negative. I'm going to insert some more rows. Okay, and this time, oh, wait. I want you guys to, we're still going to use degrees. Okay, I'm going to use degrees. All of these degrees. Okay, but I'm going to have to reverse the order. I'm going to reverse the order. So this guy is going to be here. Why do I make those changes? Well, I want to make it negative degrees. Negative. So you're going to do these. You guys with me? So this is a negative, negative. These are going to be negative. You guys follow me? Once we've done the positive piece, and we can do the negative piece. Now let's see, what do we do? 89 degree, 89.99 degree. So this makes it so much easier, right? You check those numbers for me, okay? One more. Last one. Everybody must do this. Okay, everybody please do this. This is going to be so good for you. This is going to be so good for you. This is something your calculus professor typically would not have time to do for you. Okay? You are in for lucky treat. My professor never did this for us. Okay, so what you need to do? We already did those work, we just changed the sign, right? And you're gonna do all of these.
For that, we must be in radian mode. Pi over 3, pi over 4, pi over
Yeah,
6.
we're just, yeah, it's already being converted to radians. Okay, for these, you do radians. For the others, you do the degrees because it's just so much, it's just a little bit easier, okay?
Yes,
So
yes.
10 negative pi over 3. And this is 10 negative pi over 4. Negative pi over 6. For these three, you have to do the ARD, okay? Because these are negative angles measured clockwise. Okay? So in this case, negative 89.999 would be 269. No. Do you mean tangent negative 89.999 degrees? You should get a number smaller than that. It should be a negative number. Wilbur, could you check your answer?
I got the value for tangent negative pi over 3. Type it in the chat, person.
Let's see. In radian mode, tangent negative pi over 3 is negative 1 point. For pi over 3, for these special angles, you don't want to convert them to, but you could if you want to just do a comparison.
Would the answer be negative radical 3?
Yeah, absolutely. For these special angles, you guys need to do the way your professor wants you to see. Okay. Okay, I'm going to show you what we want to see. Okay, so I represent a big group of nerdy math professors. Okay, so I'm going to show you what we like to see. We like to see, okay, when you work with tangent negative pi over 6, you are aware the angle is measured from standard position clockwise. So this is your terminal, okay? And then the blue number is negative half. And the red number is √3/2. All right, so that's going to be negative. Never ever forget ARD. Do everything from ARD. Will you? Because we want to drill that ARD in your blood. And then you will be invincible. Got it? And all these special numbers, they're to serve that purpose. Because eventually you want this subject matter easy to you, right? How do you make it that way? I found a way. I have to share with you. Just doing everything with ARD. And then it will come natural to you. And it become easy to you. And then you're going to ace everything. Okay? So this is going to be, sorry?
No, I was just going to say the answer for negative pi over 6 would be negative radical 3, right?
Absolutely. You are absolutely right. And you are going to get better and better at this very quickly. I assure you. At the beginning, you use ARD may seem to be long, right? And soon enough, you use ARD, it's like a bliss. ARD is already just a flash of thought in your mind. It goes through it. You get the answer right away. So you get better and better and better and better. Okay, and soon enough, you give you a trick question, you know this is A to D, D to R right away. Yes? Just like driving, right? Remember how my driving experience? It was hard for me to get it, right? I was driving a stick shift. But now I still driving that stick shift car. My husband just left us, you know, his stick shift car. It's like a natural. I don't even have to think about which one is a clutch, which one is a brake. Of course, I'm looking forward to the electric car. But that's what practice makes you. Practice makes you perfect and makes you more free. And you will be free at last. Don't you want that? Yes? You want it, right? Do you want it? You'll be free at last. And ARD is the way on trigonometry. Okay? But you have to put in the work. Freedom is not free. Okay? All right. So keep going. Right? So this time you should get it pretty quickly.
It should be -1, right?
Exactly. How about this one?
-3.
Perfect. Are you doing this faster and faster? Right?
Yes.
At the same time, ARD is in your head. ARD. Angle, you know? And you look at the blue number, and soon enough, you're doing those algebra in your head. By the time you're in calculus class, your professor does not need to see this. They just need to see that. Okay, so let's look at the points. Why do you suppose I arrange the points in this order? I make a special effort to make the point in this order, right? Because I want you to see from smaller to larger what the output. When the input is getting larger and larger, the output is getting larger and larger. What concept is that? Increasing. Right? Increasing. Definition of increasing function. Right, so everything we arrange here, there's a reason. So these recording probably is worth you watching again, I believe. Okay. So this is -π/6. Input output. If anything you see is a consistency. Consistency. That's the beauty of mathematics. Consistency. And next, sorry, I only wish I have a larger board. Okay. I only wish I have a larger board. I'm looking forward to go back to the class. Okay, so over here, so this is -π/3, comma, -√3. You see, we use these familiar numbers and doing something, and we want to observe. Observation, right? So as the input getting larger and larger, the output is getting larger and larger. The output is getting larger and larger. And now in the other direction, as the input getting smaller and smaller, the output is getting smaller and smaller. Do you guys agree with me? That's another way of saying it's an increasing function, isn't it? Yes?
Yes.
All right. So seeing what we saw over there as x approaching π/2 from smaller than π/2 in the other direction. Shall we plot the points? So we're gonna plot the points. So let's plot some points here. Okay, I know, I promise you we're not gonna do this forever, but this experience is absolutely important for all of us, especially for your, coming calculus course. We're gonna put all these points in place, right? Can you guys put those points in place? And try to put these points in place. So what do you see? So let's put these 3 points in place. Okay, let's put these points in place. Red dot. One more, negative pi over 4, negative 1. One more, negative pi over 3. And this time is root 3, negative root 3. Boom. You see that? And going further down, what do we see? These points. So you start to see that tendency that this time I think we don't have to try to do the same thing all over again, right? To try to plot those points, because now you already see it in your mind, don't you? So as the angle approaches negative pi over 2, as the angle approaches negative pi over 2, what happened to the output? The output is getting smaller and smaller and smaller, yeah, to negative infinity, right? To negative infinity. Do you guys see that? Yes? Do you guys see that? This is the sign is approaching negative infinity. You see these numbers are getting smaller and smaller. So there's a vertical asymptote there, aren't they? There's a vertical asymptote, isn't it? So that vertical asymptote should be what? Should be x equals to negative pi over 2. Okay, so let's put that vertical line on the chart. Forbidden. I make it red card. Vertical asymptote. So this curve in the other direction, right? So when the input is getting closer and closer to negative pi over 2 from this time, not from smaller than pi over 2, it's from larger than negative pi over 2. Yes? Right? In the other direction, we're approaching pi over 2 from smaller than pi over 2. But in the other direction, we're approaching negative pi over 2 from larger than negative pi over 2. What happened to tangent? Yes? To negative infinity, right? We just drew that. We see that tendency. We saw that tendency. We saw that dynamic process. How do we describe it in calculus? How do we describe that in calculus? How we describe that in calculus? As the angle approaches negative pi over 2. Okay? From larger than pi over 2. You see these symbols, notations comes naturally to you. Do you follow me? Tangent of A approaches what? Negative infinity. You got it? So all that dynamic process now in calculus becomes just a short notation. And if you look at that notation, you reflect on the process and you start to appreciate those notations, don't you? Have you started to appreciate those notations? They are pretty neat. They are pretty neat.
Professor, I keep I keep looking at this like a philosophy behind pre-calculus. We need one semester to refresh everything. We need to learn our calculus, 5 courses, so on and so forth.
Yeah. All right. So in this whole class, we talk about tangent, but I think it's worth every second of it. Okay. I wish my professor did this review for me like that. Okay. And most professors in calculus classes, they won't have time to do this for you. Okay. You're on your own. Okay. So I hope these lectures will help you in the future. All right. But anyway, without further ado, so we're done with tangent. Let's summarize. Right. Let's summarize. Summarizing tangent. I already have the summary here. Okay, I basically, I did it with the other class yesterday, and we're approaching to the end of the class. Okay, we're approaching to the end of the class. Whoops. Summary on tangent. Okay, summary on tangent. Okay, the curve is slightly different because we use the red today. Okay, we use the red today. Domain range, no issue. Okay, so right now you're looking at the second column. That's for tangent. Cotangent, I'm going to leave it for you. Okay, I'm going to leave it for you. Okay. You guys do everything about cotangent. Okay, so you see the domain we have here. The range now is clear because it's from negative infinity to positive infinity, right? Y-intercept, X-intercept, right? Y-intercept, X-intercept. So Y-X-intercept is such. Y-X-intercept is such. For tangent, we have 2 minutes left. Why is X-intercept as such? Right, so let me just get to the, how do we find X-intercept for tangent? Okay, the last question. How do we find X-intercept for tangent? Let me get to the curve that we did. Right here. Right, we did this curve. Okay. How do we identify these X-intercepts? I'm going to make some adjustment. What are the X-intercepts? X-intercept basically is what? Is what? Where the curve crosses the X-axis, right? Yes?
Mhm.
The output is 0. Output is 0. Right? But when you look at this picture, it's difficult to identify those points, right? Because they're not the exact integers. They're not exact integers. So what do you do? What do you do? You have to understand. You have to understand. So I'm going to take just a few more minutes of your time, okay? You have to understand the meaning, right? You have to understand the meaning of tangent, right? What is the meaning of tangent? What's the meaning of tangent? It's a ratio between red and blue, right? So when we are looking for x-intercept, when we're looking for x-intercept, what are we looking for? The input is unknown. The output is 0. Meaning the blue number divided by the red number is 0. So which number will give you blue number 0 and red number not 0? You have only, how many terminals are there? Terminal 1, terminal 2. So what are the angles here? What are the angles you can create ending at these terminals? K pi, right? K pi, right? Right? 0 pi, 2 pi, 3 pi, 4 pi, you know, so on and so forth. So the x-intercepts are what? K pi, comma 0. K pi, comma 0. Okay, what is a K?
K is an integer.
That's right. Okay. And I also wish to give you another perspective, right? Another perspective to look at the tangent in intercept is that we know tangent is sine A over cosine A, right? So when output is equal to 0, when output equal to 0, right? If tangent is 0, that means what? Means then sine A is 0, cosine A is not 0. Right? So what was sine A equals 0? And that is the same to find x-intercept, isn't it? So x-intercept and tangent x-intercept are the same. You follow me? You think about it, right? All these are told from the definition, right? Tangent A equals 0, the output equals 0 will lead to sine A equals 0. Denominator cannot be 0. Therefore, all the x-intercept for sine are also the x-intercept for tangent. Do you follow me? Do you see that inner connection? Right? But anyway, there's a lot of connections. I cannot address them all in this class, really. I encourage you guys to discover, okay, to discover. And once you go through this process, I assure you, you will be so much more at ease, okay? So that's why tangent in x-intercept is k pi comma 0, and y-intercept, there's only one y-intercept, okay? For cotangent, we don't have time to do today. And I also don't want to do everything for cotangent for you today in class. I want you guys to work on it, okay? And also secant and cosecant. Because by this time, you have seen all the situations and ideas of methods of approach these different questions. And you literally can do it yourself if you understood the lecture. Okay? So I will catch up with you tomorrow. And tomorrow I will be doing the, you know, I'll spend some time on the making of the unit circle chart. Okay. And then we're going to do a bunch of other things because tomorrow we have 2 hours lecture. Okay. But anyway, I will see you guys tomorrow. Great job. I appreciate all the participation, and thank you so much, Farouz.
Thank you, Professor.
crunching those numbers for me. But I
Yeah, but-
mainly want you guys to have a hands-on experience. Okay, that hands-on experience is going to sip into your subconscious and going to help you in time of need. Okay, so without further ado, I'll see you guys tomorrow.
See you tomorrow.
See you tomorrow.